3, 2, 1, and liftoff of Discovery, hoisting harmony to the heavens.
Hello everyone, today we are taking a look at Webb, the pillars of creation, and early galaxies. As of right now, Webb is working to cool off along with the 3-month process of adjusting each individual mirror segment. Once done, the next generation space telescope will be ready to discover incredible things. This includes information on the early universe, galaxies, other worlds, and more. Here I will go more in depth into Webb's capability and future surrounding the life cycle of a star. Among many other things, Webb is expected to provide one-of-a-kind images and information on the life of a star. This is thanks to the JWST being not only extremely powerful, but infrared as well. Here Webb is expected to look inside the pillars of creation, revealing unprecedented data on the life cycle of a star and much more. A unique opportunity that many scientists are very excited about. Past telescopes such as Hubble have taken regular and even infrared pictures of the pillars of creation. However, these will not compare to what the James Webb Space Telescope has to offer. Often referred to as the birthplace of stars, the information provided will be invaluable and beautiful in a unique way. A lot of people have seen the incredible pictures of the pillars of creation, thanks to Hubble. Looking at these images, you can see part of an active star-forming region within the nebula and hidden newborn stars in their wispy columns. While the Hubble observes primarily visible light, it also is capable of infrared images. They are not extremely accurate or powerful in comparison to Webb, but still provided a glimpse into what the pillars of creation hide. Specifically, Webb is not only optimized for infrared light, but is 100 times more powerful than Hubble. To unravel the birth and early evolution of stars and planets, we need to be able to peer into the hearts of dense and dusty cloud cores where star formation begins. These regions cannot be observed at visible light wavelengths, as the dust would make such regions opaque, and must be observed at infrared wavelengths. Stars, like our Sun, can be thought of as basic particles of the universe, just as atoms are basic particles of matter. Groups of stars make up galaxies, while planets and ultimately life arise around stars. Although stars have been the main topic of astronomy for thousands of years, we have begun to understand them in detail only in recent times, through the advent of powerful telescopes and computers. 100 years ago, scientists did not know that stars are powered by nuclear fusion, and 50 years ago they did not know that stars are continually forming in the universe. Researchers still do not know the details of how clouds of gas and dust collapse to form stars, or why most stars form in groups, or exactly how planetary systems form. Young stars within a star-forming region interact with each other in complex ways. The details of how they evolve and release the heavy elements they produce back into space for recycling into new generations of stars and planets remain to be determined through a combination of observation and theory. The continual discovery of new and unusual planetary systems has made scientists rethink their ideas and theories about how planets are formed. Scientists realize that to get a better understanding of how planets form, they need to have more observations of planets around young stars, and more observations of leftover debris around stars, which can come together and form planets. Here Webb will provide a view into the life of these early stars, helping facilitate even more discoveries. Galaxies show us how the matter in the universe is organized on large scales. In order to understand the nature and history of the universe, scientists study how the matter is currently organized, and how that organization has changed throughout cosmic time. In fact, scientists examine how matter is distributed and behaves at multiple size scales in our quest for this understanding. From peering into the way matter is constructed at the subatomic particle level to the immense structures of galaxies and dark matter that span the cosmos, each scale gives us important clues as to how the universe is built and evolves. Telescopes like the Hubble have captured many beautiful images of majestic spiral galaxies. The grand spirals we are so familiar with, indeed including our own, were formed over the course of billions of years by several different processes, including the collisions of smaller galaxies. Giant elliptical galaxies are thought to also be formed by the process of similar-sized galaxies colliding, disrupting each other, and merging. In fact, it is thought that nearly all massive galaxies have undergone at least one major merger, since the universe was 6 billion years old. When we look at very distant galaxies, we see a completely different picture. Many of these galaxies tend to be small and clumpy, often with a lot of star formation occurring in the massive knots. The question of how these clumpy galaxies evolve and develop structure over time is a big open question in astronomy, and JWST will help astronomers to learn more. The James Webb Space Telescope will observe galaxies far back in time and hopefully answer these questions. By studying some of the earliest galaxies and comparing them to today's galaxies, we may be able to understand their growth and evolution. Webb will also allow scientists to gather data on the types of stars that existed in these very early galaxies. Follow-up observations using spectroscopy of hundreds or thousands of galaxies will help researchers understand how elements heavier than hydrogen were formed and built up as galaxy formation proceeded through the ages. These studies will also reveal details about merging galaxies and shed light on the process of galaxy formation itself. This process of galaxy assembly is still occurring today. We see many examples of galaxies colliding and merging to form new galaxies. In our local neighborhood of space, the Andromeda Galaxy is headed toward the Milky Way for a possible future collision, many billions of years from now. Scientists today know that galaxies existed about 1 billion years after the Big Bang. While most of these early galaxies were smaller and more irregular than present-day galaxies, some are very similar to those seen nearby today. Webb will not only let scientists peer through the pillars of creation and discover more about the star life cycle, but also about different galaxies and the complex stages throughout their life as well. Conclusion. Webb has not only reached L2, but is slowly cooling down and working on its final steps. This includes aligning each of its individual mirror segments, which is expected to take around 3 months. Once this time period is up and Webb is ready, it will begin taking images of many different things. This includes gathering information on early galaxies, the star life cycle, and much more. Here it will peer through the pillars of creation with extreme power and accuracy to discover incredible things. This will produce invaluable information and uniquely beautiful images. We will have to wait and see how Webb's alignment goes and the things it discovers when looking into the universe. Thank you very much for watching.